5 membered, and here you will get OMA. So this is your answer B. They may give this one or this one, anyone they will give an answer. So this is CSR question. So when any nucleophile attack on two rings, if they are suffering from strain, on the time corresponding sigma bond is going to be cleaved more efficiently, because 3-membered reduced strain, 4-membered also reduced strain, both becomes monocyclic ring. Here see already bicycle is there or not? Two rings become one ring, found to be more stable. That's why it is selectively attacking here. So you may ask one more question, sir, why it is attacking on this carbon? Why not other carbons? What is the reason why it is attacking on here? See, if nucleophile attacks on this carbon, this bond is going to break, and this bond stabilized by carbonyl group, conjugation effect. If this nucleophile attacks on this carbon, this bond is going to break, and this broken bond is moved toward this side, so that you will get one more double bond. So such type of influence is not observed in other direction. Okay, so if you break here you will get a negative charge. That negative charge is stabilized by conjugation, that's why you will get negative charge, double bond. So that is the reason. Photocyclodimerization and photocycloaddition is over. Next is cis-trans isomerization, very small one. Cis-trans isomerization. C. Reaction excited state is, here it is pi to pi star triplet. Okay, 7 or 8 membered rings are involved. Only 7 membered or 8 membered is involved. Higher membered or lower member not involved in this one. Cis-trans isomerism for alpha comma beta unsaturated, only 7 membered ring or 8 membered ring is possible. See, this is a double bond. Here 1, 2, 3. So is it a cis isomer or trans isomer? It is a cis isomer. Photochemical, if you irradiate, then what happens? See, you will get a trans isomer, double bond. So here it is 1, 2, 3, you will get this one. See, one hydrogen is above, other hydrogen is below. Then what is this? Trans isomer. Photochemically we can convert cis-trans isomers. Double bond developing with stereochemistry, cis. Right now what is stereochemistry of this double bond? Trans. So now what is the reaction excited state? Pi to pi star triplet. Means it is a triplet sensitized reaction. Only 7 membered ring, 8 membered ring, this kind of influence is observed. Normal rings are not expected. Suppose if you take any 5 membered ring like this is not possible. If I take 6 membered, not possible. Only 7 membered, 8 membered cis-trans isomerization possible for alpha comma beta unsaturated carbonyl. So this is alpha and this is beta, cis converting to trans. Photochemical triplet sensitizer. So this is cis2 trans. Only these two reactions are known to convert cis2 trans. Normally 5 membered rings, 6 membered and higher membered rings are not easy to involve. Even 9 membered is not possible. 9, 10 not possible because flexibility is very high. Highly flexible, not easy to interconvert. Here two bonds are cis to each other. Now these two bonds around this double bond trans to each other. Cis trans isomerization possible under photochemically. Now this is last one in that case. Pi bond migration or pi migration. One of the pi bond is undergo migration. Position of double bond changes from one place to other place. Clear? Next. Reaction exit state is N2 pi star. You can take either triplet or singlet. Both are possible. Singlet or triplet we can use. But if I want to use triplet, go for triplet sensitizer. Answer remains same. Okay. See, this is carbonyl group. Alpha, beta, gamma is required. Gamma carbon should be saturated. Alpha, beta should carry double bond. Now this is on photochemical. Okay. So your answer is this one. Double bond migrate from alpha, beta to beta, gamma. This is the answer. Photochemically, double bond present at 1 and 2 position becomes 2 and 3. This is called pi bond migration. See where initially double bond is present? 1, 2, 3. 1 and 2 positions. If you start from carbonyl adjacent 1, 2, 3. 1, 2 double bond become 2, 3. Double bond position changes. Conjugate to unconjugate. But what is the requirement? Gamma is required. See, here how many gamma carbons are present in this one? How many gamma? Alpha, beta, it is gamma, it is gamma. So where should I use? Any side. So put double bond between beta, gamma like this. Suppose if two different gamma carbons are present, a double bond like this. Double bond, alpha, beta, gamma, alpha, beta, gamma. When two different gammas are present, whichever gamma have a tendency to give more substituted olefin, that is major. So can I write like this? Why I am using this side? See here gamma 2 hydrogens are available. Here are gamma having 3 hydrogens. But I am using this gamma. Why? See if I use this gamma, you will get tri-substituted double bond. 1, 2, 3. 3 substitutions are present around double bond. But if I use this gamma, only 2. If more than 1 gammas are present, whichever gamma will give more substituted double bond, that is major. So now alpha comma beta unsaturated carbonyl 2. See what is your answer? Alpha comma beta unsaturated carbonyl converted to beta comma gamma unsaturated carbonyl compound. Is it right? This statement is given in exam. In set exam this is given. Set exam statement question. These two are important. Statement point of view. Statement wise, any question comes from cis-trans isomerism, even stereochemistry of olefin. Photochemistry of olefin, stereochemistry of olefin, cis-trans isomerism, one more is pi bond migration. Pi bond migrates from alpha beta position to beta gamma. What is the requirement? What is the requirement? Gamma carbon with hydrogen. So normally one point explain. Is it double bond is a aliphatic or cyclic? Aliphatic, open chain. But open chain never involve in photochemical reactions. That is one code to identify. Suppose if this molecule is given, go for double bond migration. Don't go for photocycloration. Don't go for photodimerization, etc. If this double bond is appear anywhere, see, whatever examples I given today class, I taken all rings only. See, I not taken even one example of open chain. Photocyclodimerization, photocycloaddition, cis-trans isomerism, everywhere I taken example as ring. See, I taken either 5-membered ring, 5-membered, otherwise I taken 6-membered, otherwise 7-membered, 8-membered I taken, but I not taken any single example of a normal double bond. This double bond I not use. See anywhere. I use? No. Suppose if normal double bond is given, say no reaction. Otherwise, if any gamma carbon is given here, then your answer is this. Only one answer. This one. Double bond migrates temporarily from one position to other position. And here lifetime is not very high. It is a temporary effect. Okay? This is not permanent. One more time, see, these hydrogens involved in tautomerism. Go this side. You will get this or not? Until and unless that energy, photon energy is released, completely disappears, then it will come back to original state. It is not permanent. See, when this molecule takes energy, suddenly give this one. After giving this one, it is coming back to ground state by giving this one. So this is a temporary relaxation of a molecule. It is not a permanent state. Is it clear? But in your examination, if they given photochemically activated site is this one. See the mechanism. So photochemically activated. Here I can write N2 pi star, singlet or triplet. You can go for ISC, you will get triplet event. Now, here one of the hydrogen from gamma, alpha, beta, gamma. You break this and migrate here. Here this is OH and here radical like this. Can I? Which hydrogen I transfer to oxygen? Gamma. Now observe clearly, what is this bond? C alpha, C beta. Which hydrogen I transferred to oxygen? Which hydrogen I transferred on oxygen? On this oxygen after activation, which hydrogen I transferred? Gamma hydrogen transfer. Followed by which cleavage I am doing? Alpha, beta, cleavage I am doing. If I cleave here, this and this, beta, gamma, double bond, then alpha, this one, you will get double bond like this. Then finally see, this is undergo tautomerism. This hydrogen migrate here, it will transfer here. Now you will get this one. This reaction looks like, looks like a NAR is 2. But what is the difference? Transfer of hydrogen followed by C alpha, C beta cleavage I mentioned. C alpha, sigma bond, C beta. What is the difference in NAR is 2? C alpha, C beta, sigma bond. But what I am cleaving? Pi I am cleaving. That's why it is called pi bond migration. It is NAR is 2 only, but pi bond, it is influence on pi bond, that's why pi bond migration. Clear? So that's why it is showing approximately equal to NAR is 2. That's why this is possible to give migration of double bond. That's it. But normal even this is also photochemically not exist. So like that you need to identify particular reaction approximately identical to which part. So that is photochemistry of alpha comma beta unsaturated carbonyl compound. So most four famous reactions are there. Photocyclodimerization, very easy, dimer. Then photocycloaddition. Addition is most important out of this all. Okay, and addition expected for part C, photocycloaddition. Next, photochemistry of 4,4 disubstituted cyclohexanone and 4,4 disubstituted cyclohexadienone. This is very important molecule. Photochemistry of 4,4 disubstituted cyclohexanone. Hexanone. One more is what? 4,4 disubstituted cyclohexadienone. Dienone phenol rearrangement. You know, dienone phenol. Dienone phenol rearrangement is one of the example in this one. So what is actually this reaction says? See, here I am writing R and R, R, R. So what is this? 1, 2, 3, 4. 4,4 dialkyl cyclohexanone. 4,4 dialkyl cyclohex 6. In means double bond. On. In, on. This one. 4,4 disubstituted cyclohexanone. This one. And what is one more? Dienone. So here one name rearrangement is also belongs to this family. This is R and this is R. This is 1, 2, 3, 4. If these molecules are appeared anywhere, be careful. Most expected questions will be there from here. Dipy-methane rearrangement, oxo-dipy also comes from this area. Photochemistry of 4,4 disubstituted cyclohexanone and 4,4 disubstituted cyclohexadienone. This is 4,4 dialkyl cyclohexadienone. How many double bonds are there? 2. That's why hexa. I am using the word hexa. Di. Here I am not using hexa. Hex. H-E-X. E-N-O-N. E-N-O-N-E. But here see A-D-I. This is called hexadienone. So, see the reaction. Here I am writing 2 alkyl. Here it is methyl and here I am writing methyl. Photochemical. Mostly alcohols, ethers are the solvents in this one. Now you will get this answer. So this is traces, low percentage. Traces amount means very small amount. Sometimes in your exam they will give traces amount. So this is found to be major. When this molecule is given photochemically, your answer is this one. Here pH both are given photochemically. Tertiary butyl alcohol, so this is the answer. So this is found to be major. Trans stereochemistry is major and this is found to be minor. See, 6 membered becomes what? 5 membered. Adjacent what we are getting? 3 membered. Here also see 6 membered become 5 membered. Adjacent what we are getting? 3 membered. You need to remember these reaction products. Keep in your mind. Mechanism, see. First I am writing two saturated groups. Here it is methyl and here methyl I am writing. Photochemically excited. When photochemical excited, what is your answer? Here it is methyl and here it is methyl. So it is N2 pi star singlet, this one. This mechanism I am writing. So if this is given in your exam, it may be 2-methyl, 2-ethyl, 2-isopropyl, methyl-ethyl, tertiary butyl, what it may be. If these two are aliphatic, so see, 3-membered ring carry the 2 aliphatic groups. Generally unexpected answer, right or not? See, there is no relation between these two, but you need to remember. I will show the mechanism. If 6-membered ring, 4th position, 2 alkyl groups are present. Now first what happens photochemically? N2 pi star you will get. Then go for inter-system crossing. Then what you will expect? Here you will expect a methyl and here it is methyl. Then what you will expect? N2 pi star, what is this? Triplet, right? Now it is a triplet state. So here what is the state of this one? Triplet or singlet? Which state it is? Triplet state. Now here how many electrons are present? 1, 2, 3, 4. Now what happens? See, here I am making homolytic fission and here also I am making homolytic fission. Then what happens? This radical combine together and forms double bond or not? And here 1 electron and here 1 electron. So what is the spin of the 2 electrons? Here see, these 2 electrons are combined together and forms double bond. This electron is left, right or not? These 2 electrons are written as it is. What is the spin of this 2 electron? Same or opposite? Same, because it is triplet. Triplet having a C clockwise, and what about this one? Clockwise. Okay. So after getting these 2 clockwise, then go for demotion of electron. Demotion. What is promotion? Opposite is demotion. You know promotion? You are promoted intermediate first year to second year. Degree first year to you are promoted to degree second year. What is the meaning of promotion? Higher standards, high level. What is demotion? Lower level. Already you are promoted, but no use, demoted. So now already activated, no use. That's why demoted. That is called demotion of electron. Demotion of electron. Demotion of electron, remember, it will excite from here to here. Not excitation, move from here to here. The 2 electrons become negative charge, and this electron carry this one. Right? So demotion of electron responsible to give negative and positive charge. Now electron is demoting from this position to here. Now these 2 electrons combine together and forms negative. Due to loss of 1 electron from this carbon, you will get negative charge. Over here, positive charge here. Right? Then see, here one sigma bond is present. This sigma bond you need to break and attach here. Simply break this bond and attach here. Then what is your answer? So here already double bond is there. What is the charge? Negative. If this bond break from here to here, can I write one new bond here? Now already this and this carry a methyl group is present. Here methyl and here it is methyl. And what is the charge on here? Now it is positive charge. Okay. So this molecule can I write in this way? Here double bond and I am writing O negative. This carbon I am writing 2 methyls like this. Can I write positive charge here? This and this both are same or not? Then this negative charge will come back here. This pi electron will attack here. So after attack of this pi electron, then what is your answer? Here this is double bond and here sigma bond. This is methyl and this is methyl. That is the answer. Here key point is this one only. Demotion. Due to excited partner having a triplet state, there is no proper stability factor. It is a triplet state, but there is no stability factor. That's why it is get demoted. So what is use of promotion? Additional work or less work? See, they are given promotion for you based on your experience, based on your work only. So if you are a more experienced person, you will do work very easily. And one more, so your experience will increases. It is same way, standards of work also increases. That is called promotion or not? So they are promoted, but no use. On that time, what is your next stage? Demotion. Promoted, energy is wasted, that's why it is demoted by transferring electron. So after promotion, if you are using this molecule directly, there is no demotion. Promotion we are not using. We are promoting the molecule and we are not using that person. Then what chairman will do? Demoted. That person, they don't have any work, go for the demotion so that they can do work. We are giving energy. We are giving energy to this molecule. Singlet, more energy. We are promoting or not? Ground state to singlet is called promotion or demotion? Ground floor to first floor. Ground floor to second floor. Ground floor to third floor. All are promotions only. Third floor to second floor, demotion. Second floor to first floor, demotion. First floor to ground floor also, demotion. So why demotion takes place? We are not using that excited partner. If excited partner is at singlet state, turns to triplet state, and still if you are not using that molecule properly, if molecule itself it is undergo demoted, and that will give a corresponding cation and anion, and that will combine together and form say 5-membered ring. Right. Demotion of electron. So second mechanism for this reaction I am writing. Two phenyls if I take phenyl and this is phenyl, and here also phenyl and here phenyl. What is the state? N2 pi star singlet, N2 pi star triplet. Now here also phenyl and here also phenyl. Same demotion of electron. Up to here it is remains same. Here negative double bond and here positive. Here pH and pH. Up to here it is remain same. Now phenyl migrate from here to here. See, phenyl migrating from this position 1, 2. 1,2 anisotropic shift, Whitmore shift, Wagner-Mervin rearrangement. This is called Wagner-Mervin rearrangement. So after Wagner-Mervin rearrangement, here O minus and here pH, and what is the charge expected here? Positive. Can I? After positive charge on this particular carbon, now this negative charge will migrate here, this will attack from here to here. So after attack, so what is your answer? Here this is double bond, it will connect here, and here there is a presence of pH, and here there is a presence of pH. See this answer, it is 5 membered, 3 membered, 5 membered, 3 membered. So in last case, when alkyl groups are present, there is no sufficient time for Wagner-Mervin. So after getting demotion, this carbon is going to be ionized and you will get a stable cation. There you will get tertiary carbocation. But right now Wagner-Mervin possible. That is the key difference. Now 4,4 dialkyl or diaryl. You can take dialkyl or diaryl. Your answer is remain same. Fourth position having 4,4. 4,4 dialkyl or diaryl cyclohexadienone. On photochemical aqueous dioxane. Use any solvent. Polar or non-polar. Dioxane. Aqueous dioxane, then you will get Lumi ketone. This molecule name is very important. Lumi ketone. So after getting this Lumi ketone, photochemically further we are irradiating same mixture. then there is a formation of phenol. Phenol, ortho, meta. Then phenol, meta, para. This is meta and here it is para. This is the answer. So when this molecule is given under photochemical, your answer is this two. Okay? Ortho, meta, diphenyl phenol, meta, para, disubstituted phenol. So what is this? Is it a dienone or not? Di-ene-one. How many double bonds are there? 2 double bonds. That's why diene. How many carbonyls? Only one. Dienone. Then what is this? What is your final answer? Phenol. Para is major as compared to ortho. Ortho and para. See, this is common position. And here ortho and what is this? Para. Para is major over ortho. What is this? Dienone. And what is this? Phenol. So in name reactions you will see what is dienone phenol rearrangement. I taken a dienone and I prepared what? Phenol. This is photochemical. But actually dienone phenol is not photochemical, that is under acid medium kinetically controlled. Clear? It is also dienone phenol only but carry out under photochemical. So what is intermediate in this conversion photochemically? Lumiketone. Remember that name. This name they given many times in exam. Sometimes they will start reaction from this intermediate. Lumiketone. This name you need to remember. Directly in choose the correct answers. In options they will use this word. Lumiketone. Lumiketone means this structure. It may be 2-aryl, 2-alkyl, aryl-alkyl, anything will be there. So if 5-membered carry, double bond and carbonyl, 3-membered is completely saturated. That is called lumiketone. So this is a byproduct. Suppose if they given only photochemical with a non-polar solvent, photochemical with non-polar solvent. Here water is very less, dioxin is high. That's why it is called aqueous. Don't use water clearly. If I use water clearly without any dioxin, on the time you will get acid, OH, C double bond OH. Now what I use? Methanol. If I use methanol, C double bond OMe, ester. So this direction after lumiketone, it is minor. No need to stress this. You stress this one only. It is always minor. Only the solvent if they given. Only methanol if they given, on the time it is major. If this is not possible. If non-polar solvent is not given, pure polar solvent is given, then this is possible. First it is photochemical irradiated, you will get singlet, later on triplet. Now these two electrons involve in bond fission. So first you break homolytically, then these two radicals will join together. If these two are joined together, you will get double bond and you will get two radicals. Here two substitutions are present, pH and here pH. So here one electron, same spin or opposite spin? Here clockwise and here also clockwise, right? Now, so break this bond. After that what happens? See, this electron, anti-clockwise electron, and what is this? Clockwise. Anti-clockwise, clockwise combine together. When anti-clockwise, clockwise combine together, here there is a formation of ring. Here ring, double bond, and here you will get pH and this is pH. So then what about electron here? Clockwise, and here one more clockwise or not? This is clockwise. If you break these two, here you will get anti-clockwise. Anti-clockwise combined with this and form single bond. Then what is this? Clockwise. So then followed by demotion of electron. This electron migrate from here to here. So after migration, this become negative, 3-membered as it is. So here double bond, and what is the charge here? Positive. Clear? Next. After this, break this bond and attach from here to here. So after attachment, this carry negative, double bond, and this is positive. So this bond if you break and attach here, you will get pH and this is pH. So this negative charge migrate here, this bond migrate, finally you may get Lumi ketone. So what I prepared intermediate? Lumi ketone. First you prepare up to Lumi ketone. Now, so photochemical irradiated this one more time. Here it is pH and here pH. Now you will get N2 pi star singlet. Then ISC, intersystem crossing. Same one more time. Two phenyls will be on this position. So after getting this, see, this is N2 pi star triplet. N2 pi star triplet. Then what happens? See, break this bond. Photochemically activated. These two radicals are joined together, and here it will be clockwise and here also clockwise. Okay. Then what about here? There is pH and here one more pH. So now break this bond. So after breaking this bond, what happens? See, this radical combine together and forms double bond, and here double bond, and here it is O minus, radical clockwise. See, if this electron combine, you will get double bond, and you will get one more electron here or not? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 carry clockwise, and what about here? pH and here pH. Clear? Then followed by, here go for demotion of electron. Now this electron demoted from here to here. So after demotion, what is the charge expected on oxygen? Negative, here positive, here pH, and this is pH. Okay? Then see this. This phenyl migrate from here to here, 1, 2, Wagner-Mervin rearrangement. So if it is shifted here, double bond, here O minus, here pH, and what is the charge over this carbon? Positive. Okay, and here one hydrogen atom is present. So this will take this hydrogen, this bond will migrate here. So after migration of this, what is your answer? Double bond, and here pH, double bond, and what is this? Phenol. That is your answer. This is your first step. Second step, see, here phenyl migrating from here to here. Now what happens? See, this phenyl is going to migrate from here to here. This is your first step. Now this is second step. If this phenyl migrates here, this double bond migrate here, it will migrate here. Okay, then where you will get positive charge? This phenyl migrating from here to here. This double bond migrates here, this will carry negative charge. And what about this? This is pH, and what is the charge? Positive. Okay, so driving force is aromaticity. Remove this hydrogen taken by this one. So after taking this hydrogen, double bond, here OH, here pH, and here pH. That is the answer. Para position. Now migrating group is at which position? Initially it is migrating at which position? Para. It is migrating at which position? Ortho. Ortho is this, ortho migration, and this is para migration. Okay, and one more. So where you observe lumiketone, this is your lumiketone triplet state or not? This is lumiketone triplet state. So now you got this one. So after getting this, what happens? See, I don't want to cleave this side. If cleavage takes place this side, then what happens? This radical combine together and forms. What do you expect? See, double bond, and here it is clockwise. This radical, double bond. Now, is there any bond between this carbon and this carbon? No bond. So can I write a single bond here? And what is present? pH. Now spin of electron is this, right? Now go for demotion of electron. Demotion of electron. Now this electron migrates from here to here. So then what is the charge on oxygen? Negative charge. This is negative, and here it carry positive on this particular carbon. Okay. Next, this negative charge migrate here, this bond will migrate up. Okay. So after breaking this bond, here you will expect a ketene, and here double bond, and here double bond, and here pH, and this is pH. So what is the solvent given? Methanol. Methanol is the solvent. When methanol is given, this will directly attack here, back to back resonance, and it will come back here. So here you will get double bond, and here double bond, pH, this is double bond, OMA. That is the answer. Open chain product. This is open chain product, that is minor. That is overall reaction. Write down clearly. Your target is this one, lumiketone. After getting lumiketone, then one more time photochemically activated, you will get two directions. This is major direction and this is minor direction. Sometimes exactly from middle they are asking. That's why this mechanism is most important. Exactly from here they will start. They will give this symbol and photochemical symbol they will give. So proceed like this. Suppose if solvent is mentioned methanol, go for open chain product. This side you should go. You create exactly middle up to here. Later on you create triplet state. From here onwards you write down two reactions, right side one, left side one, with solvent. With solvent is left side, without solvent is right side. Non-polar solvent, polar solvent. Up to here two diversions will be there. So up to here you write down clearly, like this you write down up to here. After these two lines, right side non-polar solvent, left side polar solvent. Always right side is major. Phenol formation is major every time. If non-polar solvent is given, yield is very high, approximately 100%. If polar solvent is given, yield is more than 90%, still it is minor. This side open chain products are given or not, that is minor always. It may be polar or non-polar. Always phenol formation is major in this one. So wherever I written yellow boxes, from there onwards reaction is getting differentiated, especially this one. So this cleavage is goes right side. This is A cleavage, direction A. Now this is B cleavage, direction B. Right side is over. This is minor, no need to stress this side. Need to know mechanism, but minor is this one. If these options are not given, then go for this side. But always phenol is major, because concept is aromaticity. Molecule attaining aromaticity, that is a key factor. Now, key point in this one, see, next class I will explain applications on this one. How to predict answer. See, is it meta position or not? Meta position is fixed or not? Whichever group is migrating, that will stay on which position? See, this position is meta or not? If this phenyl is migrating at ortho, so you will get ortho answer. If this phenyl is migrating at para, you will get para answer. Which position is not migrating? Meta. Means, remember, this carbon, see, this carbon belongs to para position of this one, this carbon. Now this carbon becomes a, this is a key point for applications. This carbon having two phenyls or not? See, this carbon having two phenyls. Later on, after writing reaction, that particular same carbon changing their position over here. Now this carbon coming from para position to meta position. Try to understand this point. From this only we are writing applications. If you remember this point, you can write the answer directly. Otherwise you need to write total mechanism. First you take dienone. You focus this carbon. This carbon comes from here to this position. Here to here. So initially this carbon carry two phenyls, right? Initially this carry two phenyls or not? Initially para position, now it is at which position? Meta. Whichever group is migrating, that will go either ortho and para. Whichever is not migrating, that will settle down at meta. So that's why this position is this. You circle these 2 points. Okay? Only with these 2 points only they are asking questions. With these 2 points, this and this point. You need to confirm which is a migrating group. So problem with these 2 points only, you focus on this point. Now this point is belongs to exactly opposite to carbon. It looks like para. Now that carbon changes to which position? Meta. Para carbon, initially it is not para, because if it is aromatic ring, then only we can say it is para. But casually I am saying para so that you can identify the position. See, this position is exactly opposite to this or not? It looks like para. Now this position comes from here to here. Indirectly I am saying that, suppose if it is a asterisk symbol, isotope, if this carbon is isotope, now this isotope comes here. Clear? That rearrangement you need to remember. What is the position of that carbon, where it goes, and which group is migrating. So don't think that this position is belongs to this one. Wrong. What happens, see, suppose if you assume that this carbon is this one, then what you will think? You will think that this phenyl is a migrating group. You will think that this is migrating group. It is migrating from here to here or not, generally. But actually what is migrating group? This phenyl is migrating group. Actually it is migrating from meta position to which one? Group is migrating from meta to para, meta to ortho. Suppose if you don't know mechanism, what you will think by watching these two, what you will think is, this position is this one. Now one phenyl migrating at meta position. That is wrong. Clear? Try to remember this point. If you remember this point, one 4 marks question or any interconversion will be in your hands. Same as it is in case of dinone phenol rearrangement. But that is carried in presence of acid medium. That is a key difference. So take down up to here. Applications we will see in your next class. We will stop here. So tomorrow same schedule. So evening schedule will be given in your WhatsApp group. Okay, we will stop here. Just